Eric, good
Alrighty.
morning.
Good morning, Glenn.
Hey, we left off talking about fill rafters, but
Right.
today I'd like to expand a little further and talk about continuation hips. It's a term that I've used a lot over the years. I'm not sure how prevalent the term is, but what we talk about when we say a continuation hip is a hip that cuts off where it hits the ridge below it. Okay,
Okay.
so what you see on your screen in front of you, do you see my cursor?
Yes.
Okay, so my cursor is right there. I just highlighted what I call a continuation hip. It's a little hip that continues the roof plane from a ridge that's above to a ridge that's below.
Okay.
All right, let me zoom out and I'll show you what I'm talking about. What you have is two different spans here. You got an 18-foot span from this wall to this wall down here, and then you have a 2-foot offset over here on this corner. This corner right here
Okay.
is is 2 foot. All right. So that means that this 18-foot span, this 18-foot span has common rafters that have a specific run leading up to that ridge. And that common rafter is the same as this common rafter. And what you have is you got a 4x10 hip. And now you have another ridge down here that centers in a 16-foot span. So because there's 2 feet of difference between one span and the next span down, basically the run of this rafter is 1 foot longer than the run of this other rafter. If I was to move this common or over to there, you see how that lines up right there at that spot?
Right. And that's a 2 foot difference.
Right. Well, there's a
Okay.
12-inch difference in run between one or the other. So, how do we determine what the run of this continuation hip is? This little block here, it's not very big. It wouldn't need to be a 3.5-inch thick piece of lumber to make this transition from this point to this point. But for convenience sake, and because we can just make it out of a scrap that happens to be laying around, and because it's going to oppose this full length hip on the other side of the ridge, and because the hip, perhaps the engineer has a connection drawn. Maybe he has a detail here that shows this hip cut like this. Probably he's got this hip bolted to that hip through the ridge.
Okay.
Okay, so now visualize this. Let me rotate it a little bit so we can see it a little better. Okay, this little hip here is tricky. And it it can, if you don't think about it correctly, it can twist your brain up. Okay. Okay, so this hip opposes the longer hip on the other side of the ridge, and they sandwich a 4x10 ridge here. You'll notice, you see how I've got this thing trimmed down? See how this hip doesn't have you see how this angle? This is angled down from that point.
Right.
Well, what degree is that angled down at? Can you guess?
18.97.
18.43.
43.
And
Okay.
how do we get that? And how do we get that? we take 4 divided by 12. Okay, and then we take tangent to the -1 power. There it is, 18.43. So that's the angle that wants to drop at. If I was to draw a straight line from this point over to here and then measure that angle, it would be 18.43 degrees. That's what you'd lose off that hip, off the end of that ridge right there. Okay.
Okay.
Now, okay, so anyway, you got a big hip here, a longer one that goes all the way down to the corner. And you got this little tiny hip here that finishes this out. It makes the transition from this upper ridge down to this lower ridge. You see how I've run this ridge all the way over to hit this common?
Yes.
That's so it's easy to set it up. I do that because it makes it easy to set it up. All I have to do is take one of these commons over here and slide it over there next to that common and scribe it to mark it. And that's where that ridge runs in at. That's how it, that makes it easy to set it up so that it planes correctly. Okay.
Okay.
Okay. So now that we have this, we need to know how to cut this little piece of continuation hip to make it work. So how do we do that? How do we determine what the run of this continuation hip is going to be? Well, we subtract the run of this common from the run of this common, and then also subtract 3.5 inches, because that's the thickness of this 4-by ridge. And what do we end up with from this point over to this other ridge? That's the question we're asking ourselves. Well, we know that this is a foot from this point over to that ridge. Why? Because one span is 18 foot and the other span is 16 foot. So no matter what, these, as long as these two ridges are the same thickness, which they are, this run is 12 inches longer than this run. So if we take 12 and we minus 3.5 inches from it, then we know we have 8.5 inches from this point to this point. Horizontal now. I'm not talking about on a pitch. If I draw a line from this point to that point, and we move it so that we can get at it. Let's move it over here where we can get at it. Now, what's the length of that line? 8.5 inches, right? There it is. Length, 8.5 inches. Okay, so now that we know what the distance is, the horizontal distance between this ridge and this ridge, okay?
Right.
Now, you got to realize the reason we're trying to calculate this is because we don't have this up in the air yet. We got to pre-cut all these pieces on the ground. We're cutting this, and we're expected to be able to cut all these pieces, band them up into a package, and send them up there with a forklift. We don't have the luxury of being able to measure this. We have to mathematically determine what the length of this thing is.
Okay.
So how do we do it? Take our 8.5 inches, multiply it by 1.4142, which is the secant of 45 degrees, right?
Right.
And we get 12.0207. Then we multiply it by the secant of the 4 and 16.97, which is what this thing rises at, which I happen to know is 1.0276. 12.74. There you go, 12 3/8. Catch it? 12.350062, close enough. If I mark this little piece here, and you realize it's the same length on, this thing here is going to be the same length from short point to long point as it is from short point to long point on this side. It's the same. Or from the center, doesn't matter. Center to center, this edge to this edge, or this edge to this edge, it's all the same. As long as you use 4 and 17, or 4 and, more precisely, 4 and 16.97 as your rise. Now, how did I come up with the number 1.0274? Well, I took 4 and I divided it by 16.97, and that gave me a decimal that I could take the tangent to the -1 power of, and it gave me 13.263 degrees. That's what this little hip rises at, is 13.263 degrees. Well, what's the cosine of that? And then what 1 over x? Bingo. That's where I got my 1.0274. That's my secant of what this little hip is. In fact, it's the same secant for any length 4 and 12 hip. We're talking about the same thing right here, okay? Okay, so now, if I hit my little measure and markup tool, okay, bingo, there it is. See? See how it's the same length on this side as it is on the other side? And now, like I said, there's no reason why this little piece here, there's no reason why this little piece had to be 3.5 inches thick to carry that distance, but it's for convenience. It's so that you have something to bolt to. If you're going to run bolts through and bolt this hip through this ridge to that other little hip there, it's convenient. Or maybe they'll use those Simpson SDS screws to mount this. But you see how cleanly that all planes?
Right.
You see how nice and clean all that is? It planes just like a dream. See?
Right.
Well, there you go. That's how it's done.
Okay, thank you everybody for watching. And if you have any questions about the calculations or anything at all, please leave them down in the comments and Glenn will get back to you very quickly. Thank you.